internet so slow in the dorms, but super fast in the engineering building?
That's because they've got different network configurations. Have you ever heard of VLANs?
No clue.
Let me break it down for you. University networks are not only Wi-Fi and cables. It's way more complex than this. I'll show you how it works. A VLAN allows us to group devices logically, not physically. For example, all student devices can be placed into VLAN 10, professors into VLAN 20, and administrative staff into VLAN 30. Even if their computers are plugged into the same physical switch.
So, how my laptop connects to the university network if it don't have a correct IP?
Because every time you connect to your laptop, something called DHCP sets the IP address automatically.
So no one sets IPs manually?
No, exactly. And then DNS translates website names into IP address, kind of like a phone with a book of internet. Once routing is set up, devices can talk across VLANs, but they still need addresses. That's the job of DHCP, or Dynamic Host Configuration Protocol. Instead of assigning IP address manually to hundreds of students and staff, a DHCP server automatically handles IPs, subnet masks, gateways, and DNS settings. It's like a hotel receptionist assigning rooms, fast and organized.
Because you know how the university network works? Because Dorian explained me about it, how it works, but I have another question. If there's so many things, how they manage to work with each other?
Yeah, let me explain. It's because
To manage and maintain network effectively, we rely on several essential protocols like FTP, NTP, STP, SSH, and Telnet. FTP allows us to transfer files like configurations, backups, and software updates between servers and devices, making file management across the network easy and centralized. NTP keeps all devices synchronized to the same time, which is vital for accurate logging, security, and coordination of network tasks. STP, or Spanning Tree Protocol, prevents loops in our switched network by automatically blocking redundant links, ensuring stable and efficient data flow. For remote management, we mainly use SSH, a secure protocol that encrypts all traffic, protecting login credentials and command sessions. Telnet offers similar remote access but without encryption, so it's only used in isolated or test environments. Together, these protocols helps ensure our network remains secure, synchronized, and manageable.
Dorian, Paul just told me that you explained to him how the university network works. I also explained to him a little bit. I also have a question about how we can only access certain websites and exams.
Oh, you know what is a firewall? Firewall is a thing that helps the university to prevent from cheating, like going to the another websites by students, including like websites like ChatGPT, IT exams, or other things. A firewall protects the network by controlling what traffic is allowed in or out. It acts like a security guard, blocking unauthorized access and only letting trusted data through. In our setup, it separates the internal network, the DMZ, and the internet, keeping sensitive systems safe from external threats. It's a key part of our network security and the first line of defense against attacks.
Wow, I didn't know that the network is this complex.
Yeah, makes me respect the IT team a lot more.
Right. It's not just plugging cables, it's a whole science.
Now when I say Wi-Fi is done, I will actually know why. Welcome to our campus network topology tour. I built this topology with my friends Dorian and Beccaris. In this diagram represents a well-structured and secure enterprise network designed for SDU University environment. Let's walk through its components and the logic behind it. On the left we have the DMZ, or demilitarized zone, an isolated part of the network that contains public-facing services. This segment includes the DNS, FTP, NTP server, and backup server. It's for the name resolution, for eternal file distribution, for time synchronization, and to store and manage data. These servers are all connected to switch labeled DMZ switch, with static IP address from the subnet 90.214.26.0 on the 27th subnet mask. The DMZ is protected by a dedicated firewall, preventing direct internal access from outside and controlling communication carefully. And the second, the headquarter firewall device is the central firewall. It inspects all incoming and ongoing traffic between the DMZ, internal LAN and outside world. Traffic from here moves to the HQ ICP router connected with one link and eventually reaches the internet represented by router 2911. On far right we see simulated cloud area with a Google server and VM to demonstrate external connectivity and remote access. In the third, we have at the center of the topology are two multiplier switches. They are connected via LACP Ethernet channel, providing redundancy and load balancing. These core switches handle inter-VLAN routing, ensuring traffic between the departments like business, engineering, IT, art is efficiently routed. Each department has its own VLANs dedicated access switches. Health and science, business, engineering, arts and IT department. Each department switch like Bus SV, Eng SV, Art SV and IT SV connects to the multiple PCs and laptops within their VLANs. All VLANs use DHCP to dynamically assign IP addresses. DNS and interpreters in the DMZ provide name resolution and time services for all internal devices. FTP server is accessible from specific zone based on firewall rules. This network has multiple security mechanisms like VLANs for segmentation, firewalls for access control, inter-VLAN routing through core, static routes between critical zones, STP to prevent switching loops, SSH for secure device management. In conclusion, this topology represents a scalable, modular, and secure campus network. Services are separated using VLANs and DMZs, redundant core routing ensures uptime, security is implemented at multiple layers, and external access is carefully managed via firewalls and VPN links. It's a great example of applying best practices in network design, service availability, and cybersecurity, ideal for educational institutions or enterprise environment. Thank you for your attention.